All right, welcome to CIS 137 Class 2. Hi, how's it going, everyone? There's a short picture of me for you. All right, so last class we went over HTML and CSS, and really it was a collection of guides that you independently have to go over for HTML and CSS to get up to speed. Uh, this class is going to work like that, at least in the beginning, where it's going to be a lot of independent work, where you're going to have to go through tutorials and really learn as much as you can about that topic before we move on, so we can utilize that later. We will be going back and learning more of the nuances of HTML and CSS. That section was just intro, and here we'll be continuing that trend. So today we're going to be learning about JavaScript, and here's what one of the experts in JavaScript has to say about it. Fortunately, JavaScript has some extraordinarily great parts. In JavaScript, there is a beautiful, elegant, highly expressive language that is buried under a steaming pile of good intentions and blunders. This is from a book called JavaScript.
1/3 is about
JavaScript, the Good Parts. All right, so today we're going to do an intro to JavaScript, an intro to Git and GitHub, and I'm going to introduce you to the course-long project through the first assignment. So remember, with the course-long project, actually 5 assignments total, one being the final cumulative project. So this is the kickoff for all of that. So again, it's the 20s because we're going to limit each section to 20 minutes. JavaScript, infamous JavaScript. JavaScript was first created about 20 years ago, 1995, in order to manipulate what is known as the DOM in web browsers. Not only that, but it was to handle clicks on elements and other interactions the users can have with the page. So DOM stands for Document Object Model, and it's basically the HTML, or what the HTML gets turned into in the browser. So the browser keeps this big graph of how all the HTML elements are nested and where they appear on the page, keeps all the properties in there. And JavaScript was written to go into that object model and manipulate it and change things. And you can add new elements, or you can move them to another section, or change their position, or change their color, or change anything about them. You could add listeners to say whenever a user hovers over something, you could fire certain scripts. That's when it was first created, and it was actually created by one guy in 10 days. So it was just meant for the Netscape browser. It wasn't called JavaScript back then. I think it was called Mocha, and then LiveScript, and then it became JavaScript. Not to be confused with Java, but really they wanted people to be confused because Java was popular at the time. Java was still popular, so they made it JavaScript to get people that are interested in Java to come over and try out JavaScript. But they're completely different languages, so they're not really related otherwise. So that was back then, but now JavaScript has pretty much taken over in the world. You can use it on server-side development, you can use it in mobile development, you can even program games with it using Unity, it's a free framework. I'm talking about like fully featured 3D games with virtual reality, all in JavaScript. And you can do serverless programming with it, which is something I'm particularly fond of, where you can run your code in the cloud without having to configure servers. So this course, this is not an intro to programming course necessarily, but you will be learning a lot of programming in this course. And if you haven't programmed before, it's going to be kind of jarring. The initial learning curve for programming is pretty steep. But once you get past that learning curve, which may seem somewhat insurmountable at times, then it flattens out a little bit for a while. So instead of just jumping in directly to JavaScript examples, I recommend this intro to programming from Khan Academy. This will actually go from the question, what is programming? And then it ends with an actual learning tutorials. And these tutorials come with their own videos, and they're basically, they don't have any HTML in them. They don't have anything else. It's just pure JavaScript, and you can so conveniently, not only is it teaching programming, but it's still in JavaScript, because JavaScript's a pretty relatively easy language to pick up, only because it doesn't have a lot of syntax requirements that other languages do. But they could have done this in any language. It's just, it runs in the browser, which makes it easy, and it's not as hard in syntax as something like Java, where you have to have a bunch of stuff written before you could even start coding. So definitely check that out if you haven't programmed before. And I know some of you at least have taken classes like 132, and if you took a class like that, then that's basically what's covered in here. So you can check it out, but you probably already know about everything in this Khan Academy video. Programming is not easy. I don't want you to struggle too hard in this course with programming. If anything's seeming way too hard or anything, please don't hesitate to ask for help. Either you can ask programming questions on Slack and the general channel. And again, like last class, I explained, if you help other people, if you have a good conversation, you'll get points, and those points will be applied at the end of the course. Because each point is worth since we have 1,000 points, each point is worth about 0.1% in the total grade. Yeah, in this particular course, Intro to Web Development Tech, there's not going to be any really intense algorithms or anything in this course for the programming side, and I will give hopefully good targeted examples for the exact code you need to write for the sections. So watch the intro, go through the exercises. If you're probably still going to be struggling with programming after that, just let me know if you are, and we can work things out. JavaScript resources. So in the book, there's a couple chapters on JavaScript, but really the only pages that apply to what we're going to be doing are pages 498 to 511. The book is very heavily jQuery based, and jQuery is a JavaScript framework that we're not going to be using. The reason is jQuery is kind of hard to explain, but until we learn about React and its differences from jQuery, but I'll give it a shot. So jQuery is an extension of JavaScript to make it a bit easier to manipulate the DOM, manipulate the HTML elements on the page. But and it's good because every browser has a different way it likes to interpret JavaScript. So jQuery provides a universal way that you can use JavaScript that will be rendered the same in every browser, or at least it tries to be. That's its goal. But the way we're going to be generating you're using JavaScript, we don't need jQuery because we're actually going to be building the pages in JavaScript instead of building the pages in HTML and then manipulating them in JavaScript. So that'll make much more sense later next week when we go over React and JSX. So after you do that programming tutorial, there's a site called javascript.info. Now here you should go over chapters 1 and 2 for JavaScript for the intro. This site is actually really great. I learned something from it the other day. This whole promise, I've been using promises in JavaScript. But we're probably not. We'll talk about this a little bit later. But there's this new async await that definitely learned something from this site. So this site is very informative. javascript.info. So again, each chapter starts with an introduction to JavaScript, and it actually starts at a place assuming that you don't really know what programming is, at least JavaScript, especially JavaScript programming. It's very good. So again, with all these resources, please give me feedback if you don't feel like these are good resources, or you have suggestions for better resources, just let me know. But this one I think is really good. Just like HTML, you can write JavaScript in WebStorm or other IDEs, or you can even do it in Notepad++ and TextMate. JavaScript doesn't need to be compiled like some languages like C. It is just run straight from the source code into the browser. So you can just write up JavaScript in a text file, and then it will execute on the browser when you include it in your HTML. Then, just like the other sections, you should do at least one of these interactive tutorials. So I left Khan Academy out because they're up here, and I couldn't find an equivalent tutorial on their side. But Free Code Camp, or the basic JavaScript, you see it takes 10 hours. Do as much of it as you can. And this one's completely free. It's great. And just as good, oh, you guys can see that. Okay, let me pull it up. Free Code Camp, here's what it looks like. It would be under map basic JavaScript. Basic JavaScript. Branch out that way. So you just have to scroll down until you find basic JavaScript. And then you can begin the it's in browser. It's nice. So it starts with comments in this one. The comments are just a way to write code or write English in your code that doesn't actually get interpreted by the computer. So you should write a lot of comments in order to clarify parts of your code or what you're trying to accomplish. And it's kind of weird that it's starting with comments because, what are you supposed to comment then? So try creating each one type of comment. So you can say single line comment. This is a comment. And multi-line comments look like this. It just starts with that /star, and it has to end with a start slash. It has to balance out. There's a lot of stuff like this in programming where it has to balance out with something that occurred earlier. It can get pretty difficult to see how far you're nested unless you use good styling conventions, which we'll talk about later. So once you raise the roof, you can go to your next challenge, and it jumps right into variables. So these are good. It assumes you don't know much about programming at all, so it has a good description over here, and we'll put it over here. So again, yeah, some of you have taken programming before, some of you haven't. So I'm not going to spend a lot of time in class going over the fundamentals of programming at this time, but if anyone has any questions, I will be glad to talk about them. JavaScript on Code Academy. If you think one's shorter than the other, go to the catalog here. You see the JavaScript section here is also 10 hours. But there is a paywall here eventually. Mainly there's this pro that's like, this is like 20 bucks a month. I'm debating getting this. But what they provide in the pro area is quizzes and projects, but you can do all the lessons without having to pay for pro. So it says, this one, hey, let's get to know each other. What is your name? Write your name within quotes like this, and then click save and submit code. We did it. So this one, it has a different approach. It's starting with a string variable, and then going straight from there and how to work with that string. So you may like one or the other. You can let me know which one seems better for you. There should be a Q&A slide here, but there isn't. So I'm going to ask you guys, do you have any questions at this time? Any comments? Anyone want to hear any more about specific things about JavaScript? Again, just like HTML, CSS, I'm not going to teach you all of what there is to know about each of them. These are very, back in the 90s when this first started, when HTML and CSS and JavaScript came onto the scene, there wasn't that much you could do with them, and it's pretty basic. But it's been over 20 years of development. There's a lot packed into them now, and JavaScript is now, a first world citizen as far as programming languages are concerned. It has a lot of power to it. The current JavaScript has splintered a lot too. So not only is there just plain JavaScript, but then the standards committee. So like we said in the first slide, JavaScript started in 1995. But sometime in the 2000s, this place called ECMA, group called ECMA, took it over. So ECMA is a standardization for computer science corporation or organization, association, we'll say, right here. Standardization, Information and Communication Technology, Consumer Electronics Industry Association. So within, they have something called ECMAScript, and that's still JavaScript, but it just is a more standard compliant version of JavaScript. The one I use is called ECMAScript 2015, also known as ECMAScript, or ES6. Very confusing, all the version numbers. And I believe ES7 is coming out sometime next year. But ES6 is gaining a lot of traction and is used in a lot of places. Not only is there ECMA, but then there's TypeScript. Yeah. TypeScript is a language that sits on top of JavaScript. So you can write your code in TypeScript. Well, this is gaining a lot of popularity. And then you use what are known as transpilers to change the code you've written in TypeScript into JavaScript that the browser can run. So JavaScript becomes like the compiled program of TypeScript. It's really transpiled, is what they're calling it. Not only is there TypeScript, there's CoffeeScript, is another somewhat popular one. So this one also transpiles, so you can see this code on the left is the same. This is CoffeeScript over here, and on the right is all the JavaScript that would be written instead. Pretty similar, but they knock everything off. JavaScript and ActionScript. So ActionScript, I believe, is for Flash. Yeah. So there's not really a relationship between JavaScript and ActionScript, other than ActionScript was written for Flash, I believe. It might have changed over time. Oh, okay. So yeah, it is now. It was written by Flash, by Macromedia. But yeah, ActionScript is now it is now a dialect of ECMAScript. So it looks like it may still be just used in SWF files, which are Flash files, Shockwave Flash. But it is very similar to JavaScript. I just don't think it runs directly in the browser. That's a good question. There are a few more. I think TypeScript is the biggest one I've seen. Smalltalk is another one. I think Smalltalk's actually its own programming language completely, so not related. Java, not related. Java, completely different. JavaScript has nothing to do with Oracle. What is Java? So if you take CIS 132 or CIS 232, then you've used Java. If you took CIS 105 and you use Python, and Python's probably more similar to JavaScript than Java is. So just like JavaScript, Python is an interpreted language. It's not compiled down into an executable file. It's just the code's run directly from the source. Again, in the tutorials you'll go through with JavaScript, it'll tell you about these other languages that sit on top of JavaScript. Oh, yeah, another one. Dart. Some people like this. I haven't tried this one at all. It's easy to learn, easy to scale, deployable everywhere, and Google uses it. Generally, languages that Google uses or Google creates, they are meant for people that really know all the theories behind computer science and software architecture, like optimization. So that I feel like they can be kind of daunting at first, but ultimately, if you learn how to do right with something like this, which looks very similar to vanilla JavaScript, or at least ES6, if you learn to write it like this, then it'll be better for you in the long run. But I'm not sure because I haven't seen anyone using Dart, but I know it is used. Yeah, I just don't hang out with smart enough people or something. Dart is it seems interesting, but I don't even want to bother going in there. There's so many different languages, and at this time, that some of them are just very niche and not worth learning per se, just because they're not used by many people. Yeah, I wish I'd had enough time to dive deep into intro to programming, intro to JavaScript, but this course only has so much time in it. So yeah, so you have to learn on your own, but you're not alone. Please message on Slack, and you can definitely get help. And with all the, if you don't get help from us on Slack, all of the tutorials I'm pointing you to have active communities that just answer questions immediately when you post them on forums. So don't hesitate to do that either. Okay. Let's jump into the next 20-minute section. So there's an intro to Git/GitHub. So you should have signed up for GitHub by now. But if you haven't, that's okay. You can still sign up. But github.com. Sign out. Let's play this. GitHub.com looks like this when you first fire it up. All you need to do is click this sign up for GitHub and follow through their onboarding process. This is the de facto standard for Git repositories. We'll talk about that in a second. So Git is a distributed version control system. And what that means exactly, we'll get into our next slide. But it's basically a way for people to work together on a single code base. But not only does it provide a way to collaborate, it's highly collaborative, but it provides a history of the code. So you have versions of the code. So if you ever, want to experiment with a new feature or something in your code, you can create what's called a branch, and you can work on that branch. And if you make a mistake or it's taking longer than you wanted to, and you want to work on something else, you can actually jump back in time to a version of your code that existed before you even tried to start writing that feature. So you could put on a bunch of different things at once without having to worry about totally messing up your project. You basically can write save points using Git. And it is very popular. Its popularity has been going up over time. In the most popular version control systems in the past were known as centralized version control system, and those are still used. Those are like the most popular in that line is something called Subversion, and there's also Team Foundation Server for Microsoft, but that's pretty much. But those centralized version control systems provide similar features, but in a slightly different way. There's still active debate over which methodology is better, distributed or centralized. But we're sticking with distributed. So here's the idea behind distributed version control system. So as you can see, we have two developers here working on the same code. Now up here we have a central repository. So this would be, in our case, GitHub. So GitHub would have the code available for anyone to download and manipulate. So that's what is called open source, is when someone can come in and see your code. You're just opening up to the world. The GitHub provides a way to do open source, and they provide a way to do private repositories too, but you have to pay for the private repositories. So the private repositories would be closed source, like only you would have access to that code. Now on your personal computer, when you check out a GitHub project, what you're doing is you're pulling all the code down into your computer. So all the code in the repository for that particular branch that you're working on would be pulled into your computer. Then you can make updates to the file. You can change them. You can update a bunch of them at once. Generally, it's a good idea to, make small updates. So you make your updates, and then you commit your files. You say, all right, these files are ready to go. So they get put into the repository, and then it sits in your local repository until you push it back up to the server. So when it's in your local repository, other developers don't have access to it. But once you push it up to the server, then everyone else can get your updates. Now this doesn't have the full push over here, but it's the same concept. You would pull and push into the local clone, and this other developer could do make updates to the files and then commit them, and they get committed to her local repository, and then those get you can choose to push them up to the central repository. There's all kinds of other rules in here. What if two people edit the same file? That's the biggest one. What if two people edit the same file? That's what's known. It would need a merge strategy. So GitHub and Git have these default merge strategies to try to figure out, if it can combine the changes from two different people. If it can't, then it'll say there's a merge conflict, and you have to basically go in and look at the changes made by one person, changes made by the other person, and manually put them together. It can get pretty complicated, and that's why I said earlier it's a good idea to do small updates and small commits, because the smaller the pieces, the much fewer merge conflicts you'll have. The mechanics of all this we're going to be getting into, or I'll be providing resources on how to actually do these commits and updates and push and pulls and set up a central repository. So on your computer, in order to have this local clone, you just need the Git software that I provided a link to on the syllabus. So you don't need any special extra computer or anything like that. This is going to be a software application running on your laptop or PC. So Git is very collaborative, and the convention that is being followed these days is something called Git flow. And Git flow is a way of organizing the various releases and states of your code. So when you're working on a project, you have code that you turn into your final application, and that code is what people see, right? It's your production code. That code, once you ship it out, what if you want to add a new feature, then you're going to have to change that code. And when you make changes to the code, it shouldn't affect what's already pushed out to whoever's using that product. So what you use, so instead of if you had everything still in the same repository or in the same branch, okay, let me take a step back. I'm losing myself here. So Git flow is a way of providing like standard snapshots of your code. So this master branch basically represents code that is or will be released to the public, pretty much, in the form of your product. So this code always represents what is out there. So for instance, if you're working on a new feature and a user reports a bug for your some code that actually exists in the master branch, then you can go back in time, just like I said with the being able to go back in time. You can go back in time to where that code exists, which would be in your master branch. It wouldn't have any in your feature code in it, and you can make fixes there, and then apply that fix to all your new features. But then you can release a hot fix to whatever production app you have. So that feature doesn't need to slow down a bug fix, which is great. That's why you'll get, versions of programs that just says fixes bugs, and then the next week you'll get a big update where it adds a bunch of new features. They had two different histories that the developers were able to use to update the fix a bug and be work on new features without affecting the ability to fix bugs. So it is also highly collaborative because each feature starts its own history or its own branch. So let's try to look at this. So in Git flow, there's what's known as the master branch. This is your default branch that GitHub is going to create for you automatically. So people consider this the gold standard of your code. This is the true history. It shouldn't have any bugs in it. It's your production quality code. But the process of writing software, you create a lot of bugs, and you have to debug. You have to remove those bugs later, and that's just the nature of the beast. It's like if you're writing code, you're writing bugs. Even if you are super confident in the code, it's gonna have bugs. It always has bugs. So to keep our master branch clean, we create a develop branch. And develop branch is a copy of the master in the beginning. It branches off of master, so that history shares the same trunk. Then for every feature, like if someone wants a new button, or we're going to change the type of database that the master code uses, we would create a new branch and we work on our feature inside that branch, not affecting the develop branch. So the develop branch is still clean for other developers to work on. And if we need help, we can, if you see here, this red code means it wasn't working, it's not working, it's working now. So the developer got this working now in this green circle, and they decide to push it back to develop. So they merge their code back into develop, and then right here they say, oh no, it's not working again, let's go back. So they unmerge it, come back to here, and then work on the code again, fix the bugs, and then they're able to have a successful merge later with develop. Meanwhile, this other developer came in after this code was started, this feature, and they started their own feature, and they worked on it, and then they were able to merge it back in once they were done. Once they merged it back in, this develop branch now has the code from feature dev 45 and feature dev 60. So it combines all the code together, and then that code should be tested, debugged, make sure it works, quality control, and then it goes to master branch, and that code gets shipped to the customer. So Git flow is a way of organizing your save points in such a way that the master branch is clean, and these other branches are good for developers to not feel like they're breaking things. You're allowed to break things in your branches, and you can be confident that it's not going to be affecting the other developers. The Git flow has a very short crash course on it, and ultimately, in this class, we're going to be working individually, solo. So most of the time, you're just going to be using the master branch. All this extra process is not completely necessary at first, but you're welcome to follow the process. I still, for personal projects or solo projects, I still follow this Git flow just because it's convenient to be able to jump back and forth between features. If the customer comes in and say they have a problem with something, I can say, okay, let's fire up the code. So I go back to what version they're in, and then I can run the exact code that's showing what they're seeing. Very, very convenient. Before using something like this, if the customer asks me, oh, I'm having a problem with whatever, I wouldn't be able to go back in time. I wouldn't be able to go back in history to work with the exact code that they're seeing. So when I ran my code, I'm like, well, that doesn't even exist anymore. So you just have to wait till the next release or something like that. And but that next release could take a few weeks or a month. So leaving an alert, not being able to collect time and fix that bug, and then just release that bug. This is the standard operative on the cycle using Git. Git resources. There's actually a free book online, free official book, Pro Git. And what I want you to do here is read chapters 1, 2, 3, and 6. So we're going to be using Git and GitHub. I don't need to worry about setting up Git on the server. Distributed Git, distributed workflows. This is going to be talking about Git flow in here if you want to learn more about that. Tools, that's important to know. I don't know, for Git, if I want to do something that's not like cool, I go look it up because it's easier to not keep all that information in my brain at all times. You don't worry about keys, you don't worry about getting internals if you want to. Git is integrated into WebStorm. It's not mentioned here, but it is. And this resource is great. So 1, 2, 3, and 6. Most importantly, 1 and 2 and 6. 3 talks about branches, which is will make that Git flow section make more sense that I just mentioned, talked about. But branches will be used lightly in this course. You can use them at your own will. Not as important. They're important to understand how they work for sure. But for the purpose of this exact course, you won't need them as much. Still useful though if you do use them. Okay. So 1, 2, 3, 6. But reading is boring. So there's also this interactive tutorial that tells you how to set up Git in your code base, which is going to be very important. When we get to the course on the project, you'll see you have to do all of what this tutorial is telling you to do. So this tells you how to initialize Git. So on your actual file system, like if you have Mac, you see a file system with Finder, or if you have Windows, you see it with Windows Explorer. But the way your file system is set up, you have folders that contain files. And with Git, you can basically turn a folder that contains a bunch of files into a Git repository. So it's not like a separate database or anything like that. This exists on your file system. So this is a folder on your file system. And when we use the command line, it makes it super clear what you're doing. And we're going to be using the command line in this class. And I'll show you the commands as we go. So this is what a command line would look like on the Mac in particular. You have the $ to accept input, and we are currently inside of a folder. If we look at the commands, we do these commands, great job. As Git told us, Octobox directory now has an empty repository in /.git. So that means it's a hidden directory where Git operates. So Git creates this hidden folder that contains the information needed to manage your repository. So you can go through this and it'll show you how to actually add files to your repository and commit them and then make changes and commit those. It's a good hands-on tutorial. You might have to go through it a couple times. It's only 15 minutes in order to pick up all the pieces. And then you'll need to use them in the course-long project. GitHub, Git is not dependent on GitHub. Git is basically the protocol. It's the distributed version control system design. It's all the code. But GitHub actually provides a free centralized repository. So it gives you a place on the internet where you can put your code. So Git, you don't actually need to connect to any central repository. You just be using your local repository. But I mean that to be sole purpose, it's meant as a way to share code. So having a centralized repository really helps. And GitHub is the biggest. And it's free. So we're using GitHub. There's another one called Bitbucket that I use pretty often, but Bitbucket is not as widely used as GitHub. So for learning GitHub, you could use this tutorial, and this actually is a combination of how to use Git and GitHub. And if you look over here, this try Git is actually in GitHub. They're pretty much the authority on Git these days. And there's also a graphical user interface called GitHub Desktop that lets you do Git commands without using the command line. But for our purposes, using the command line is better at this point. There are some more complicated procedures that the GUIs, the graphical user interfaces, work better for, in my opinion. But some people still prefer the command line, and operations that I think are pretty complicated, involve a lot of moving pieces, but others just swear by the command line. Look, get out of trouble. That's cool. Yeah, sticky situations. Too many small git commits. Git commit message sucks. Git committed to wrong branch. Accidental git commit. Just make it go away. Breaking things with Git. I haven't seen this section before, but it's pretty fun. So, like I said, there's a lot of disaster situations you can get into as well with any version control system. Git is more tolerant of those, in my opinion. Important note on here: once you sign up for an account, send a Slack message to me with your GitHub username, because that's how I'll be grading the projects, is through GitHub. Send me your username, and we can go from there. Any questions on GitHub or Git? Pretty crash coursey. Let's see if I have any good examples of using Git or anything like that. Yeah, I can show you some. Sure, let's look at github.com. GitHub.com has a ton of code on here, and it's not just in JavaScript, it's in every language. So we can explore, and not only do people use it to host code, but they use it to host regular documents, they use it to host snippets of code. You can even host web pages on GitHub. But GitHub repositories are places where writers can share their work with the world and get feedback. It provides a good feedback system where you can comment directly on the code. You can submit issues. You can have a wiki. It really provides a lot of good features to store a lot of different projects. So we're going to be using Facebook's React in this class. And you can see these are other popular frameworks in JavaScript. And when you go into GitHub code, it looks like this. So you can have a README that is formatted using what's known as Markdown. And it's kind of like a really simplified HTML. And it tells people how to use your project. Then it has a whole folder structure up here of all the code in the project. We're going to source, jump all the way down into the source code. It says good syntax highlighting in here. So we can say, oh, I want to see how this source code has changed over time. And this is how many commits have been made to this particular file. You say, oh, I want to go back in time and see what happened when they got a few more fiber tests passed, whatever that means. And you can see here the changes made on that particular commit. You can actually look at the exact file, but all the green lines are lines that were added, and all the red lines are lines that were taken away. When you see the way Git works, it's a line-by-line basis. So it basically took away this line, but then replaced it with this line, which is a very similar line. When you're coding, you don't need to delete a line and add a line. You just need to make your changes, and then Git figures out how to change the files or what changes were made in order to merge into a different branch or merge into a different history. So it shows all the changes in here. This file is completely new down here, so it's just pure green. And look, you can comment on a commit. You can create issues. So there's 606 issues with React. And inside here, let's find a better one. These issues can lead to discussions, and then generally they end with a resolution as well, like the code was fixed, or the issue wasn't really an issue, or there was a workaround. So not only can you have developers working on your code that you give explicit access to your repository, but people can make what are known as forks of your code, and that they create a complete copy in their own GitHub account of your code. They can make changes, and it only applies to their code, and then they can do what's called a pull request. And they can say, I want the changes I made, I want you to put them in your code. And when you do that, the repository owner of Facebook can come in and look at your changes and say, here's what they changed, the exact things they changed. And then you can say, if you're the repository owner, you could approve and merge this pull request into your code. So that's really cool. It provides a way for users to contribute to your code, or other developers to contribute to your code, but you still act as a gatekeeper. You get to control what goes into your code ultimately, but nothing's stopping them from just using their version of the code. Let's see what else is cool about GitHub. So when you if you want to check out projects like this, there's a lot of projects on GitHub. Pretty much every project, every open source project is on GitHub. There used to be other central repositories. God, I can't remember the name of that one. But everyone uses GitHub now. Pretty much everyone. I want to kind of say 100% everyone, but so when you want to actually clone the project, if you have GitHub Desktop, you can just click this button and it'll download it into a folder on your computer. Or you can download the zip and it won't actually be connected to GitHub, and this will just be a zip of the entire folder for the repository. Or you can use git commands to you pass it this URL and it will clone it, all of this information, into a path on your computer. So that's GitHub. Do this tutorial, do the try GitHub challenges, try Git challenges for the console command line Git, and read chapters 1, 2, 3, and 6 of this book. All right, let's talk about the course long project. So in this course, we have a 5-part project. It's going to get more complicated over time, obviously. This one involves a lot of setting up your environment. So the actual final product is basically the tip of the iceberg of all the work you had to put in to create that product. Now, JavaScript development or HTML web front-end development is more complicated than it used to be. In the past, a lot of people just coded their HTML by hand in Notepad. And if they needed JavaScript, they would just embed it right in the page. If they needed styles, CSS styles, they just coded theirs by hand as well. And there's still a lot of coding by hand, but the way you code by hand is different. So generally, you're going to be using a framework. when you're programming any kind of application, starting from scratch is just not feasible anymore, because you'll have to deal with all the bugs that come with designing an entire system from scratch, and it'll delay your project vastly. And plus, if someone comes in, uh, another developer from another company joins your team, instead of having to learn a whole new system, a whole new proprietary system, you get that developer off the ground running faster by having this using React. Everyone, that's the baseline knowledge that you would all share. So once you have that shared React knowledge, then it becomes easier to explain how the actual project works. So what am I going with that is that React, so unfortunately, it's not super simple to set up. Well, it is now, but it didn't used to be. So actually being able to write with React and have it work in the browser, develop with it, involved a lot of extra tools. They realized that's a problem, and they've streamlined that process recently, and we're going to be using the streamlined version, which is not too bad. Not too bad. It's actually super easy. But then, over time, we're going to be adding more features and more pieces to this that are going to involve other tools and other libraries, and it's going to be a lot of learning curves in here. But that's what class is for, it's learning. So, perfect. So course on project part 1, what are you going to be doing? So we're going to be building a website or web application that is basically a website that has a general public section, and it provides for user login, and then the users will be able to manipulate their profile and do other things. And then we'll also have an admin section where an admin can see all the users and see certain statistics or other features or tools for that particular web app. So as far as what all those features and tools and all the bells and whistles of what's going to be built, we'll get to that when we get to the other parts. But for now, we're going to create a simple what's known as a landing page. So first thing you're going to do, so the idea for this project is that you're going to create this website for a particular company, and the reason or which company you pick is up to you, but ideally it would be a local company, as you'll see later when we go through these, and we'll get into that. It'll be a local company, that's kind of like a nonprofit or something that has a website, but the website is just god-awful, ugly website. But it has like pictures on there and stuff that you can pilfer. That's the idea, is you can use their branding to create your own website. So, but a better version of it. So in this part 1, you're gonna decide what company you want to create a website for. You'll have ideas on that. Then you're going to set up your React project. So we haven't actually learned React yet at all, but I will provide links on how to do a quick setup of the project. Then you're going to set up Git. So you're going to create your folder structure to use GitHub. And then you're going to create what's known as a hero section with an image background. I'll get to what that means in a minute. And a nav section with 3 links. And you'll set the fave icon and page title. So by setting up Git, you'll also, when you submit this project, you're going to be pushing it up to GitHub, and that's how you'll submit it. So as far as picking a company or group, you should pick a community or nonprofit group that would have like events and members, my idea, I'm going to be doing this project along with you. So for examples, um, my group is going to be the Sullivan Heights Swim Club, which is a local pool that has a really crappy website, and I'm just going to make a new website as we go. So using an existing website or even a Facebook group, you can go through there and steal their pictures or images or whatever you want. These websites, we're building for educational purposes, so if we infringe a few, copyrights or anything like that, that's not a big deal on education side. Don't go try to sell this site to someone else later, unless it's that company. If you show it to them and they're like, oh, we want you to fix our site, that's a bonus. But I don't think they'll be really mad if you use their images and then if you're not selling them. So company types you could think of, or I just put out there. So I got these basically by looking for other membership list programs. Here's some ideas. So fitness, dance studios, boxing, Zumba classes. These are all very gym centric. Then there could be a nightclub. It could be a swimming pool. Tanning. If you get a tanning membership of some sort, massage memberships, CrossFit, yoga, gymnastics, paintball. I mean, you could even make up your own company, but you might have a little bit more trouble finding image content, media content, if you're doing it with a made-up company. But just if you want to do that, you could just go on Google and Google images and find whatever images you need. So don't feel limited by this idea set. It's just trying to inspire you. So that's the first step, is picking this company and group. Next, you have to actually set up your React project. This used to be a huge, huge pain to set up a React project. And the reason is because there's all these other tools involved with how you can build and host your website that all have to work together in order to make a coherent development environment. Luckily, React now provides a tool called Create React App that basically, what's the word for that, abstracts all the tools you're using away from you. And then later, once the project becomes more mature, or you want to change one of the tools you're using, you can get off these rails and see all the magic that was hidden from you, all the usage of build tools and whatever other tools are involved. So it's a good starter. It makes it really quick to start, and then it gets out of the way when you need it to. The projects I've worked on, we didn't use this because it didn't really exist yet, and just started getting popular. Okay, just is getting started. So you should have in your software requirements installed Node. Node comes with something called npm, which is the Node package manager. You can use npm on your command line to run or to install packages. What this particular command is saying is npm install -g, and this G means globally, and we'll get into that when we get into npm in a later topic, in a later class. So it's installing the global package of create React app. So let me pull up a terminal for you. That's not a terminal. Okay, so I have this terminal here. Let's go into another. Just make another one. I just made a folder called test. I'm going to go into tests, and I'm going to put a new React app inside of here. I've run npm install -g create React app before. So if I try running it again, it's going to update the package if there is an update. I ran this, it's running, it's fetching all the data, and now it's complete. That's all we need to do for installing Create React app. It has other messages on here. You can use npm to switch between node versions. This tool doesn't assume a node backend. These are advanced topics we'll talk about later. Creating an app. To create a new app, all you have to do is run create React app and then give it a name. And this is going to be the folder name. So this will be start project, or for my case, it's going to be the Sullivan Heights Swim Club. So I'll just call it Sullivan Heights Club. When you kick off that process, it's going to do a lot of things for you. It's going to install all the tools necessary to give you a good baseline to start with. Even to use certain features of JavaScript, you would need to install a tool called Babel, for example, that does transpiles into other versions of JavaScript. That's kind of, and then you would have to hook that up into a build tool and configure the pipeline so that your JavaScript automatically gets converted into JavaScript that can be interpreted by the browser. All of that is really, setting up that plumbing is daunting and annoying because sometimes it doesn't work and you don't know why, and it takes forever to debug. This is basically, instead of doing all the plumbing for your house, this is basically giving you all the plumbing up front. So the only commands you need to worry about in the beginning are these four, but really just this one up here, yarn start. If you don't have yarn installed yet, I believe that's one of the software requirements, then it'll probably say npm start here. They're pretty much the same thing. So npm start or yarn start would accomplish the same task. Yarn is like JavaScript has things that are built on top of it, like TypeScript or Dart or the other programming languages that sit on top of JavaScript. Yarn sits on top of npm to provide a better experience for npm. Oh, sorry. If you get this, can't find package.json file in your folder path, that's because you needed to follow this next step right here, which is to change directory cd into the folder you just created. We use ls, which just means list all the files in the package. You can see them all here. So we can use cat readme to view the files. We don't have to do all this. If you wanted to, you could just open up the folder, and then you can see all the files inside of here. So readme.md, that's what I was talking about with Markdown. You can open that up with any text editor, really. You open it up in a Notepad++ or something like TextMate, then it'll do syntax highlighting. In this README, you can see they talk about npm start, npm test, npm run build. These are the same as Yarn. Then talk about language features and polyfills. This is the kind of plumbing you would have to set up in order to support certain features. You have to set up all these build tools to all work together. It's very frustrating. Done it from scratch before. And once you usually do that, you're like, all right, this is my gold project now. This is what I'm starting with. I'm not going to make any changes to this. I'm going to keep on using this. So Create React App is better because it's constantly updated and it's using the latest. So yeah, your gold system would only work until you need a new feature that was not supported by your old system. But with Create React App, it's community supported, so it's being constantly updated. So all of this in this README is going to be super complicated. Don't worry about it yet. So we'll just do the Yarn start now. Again, if you don't have Yarn installed, you can do npm start. So this actually starts up a mini server on your computer, so it can host it, and then it fires up a browser and creates a page for you. This is the default page. It says Welcome React, and it has a spinning atom. That's the React logo. And to get started, edit source app.js and save to reload. So it's pretty cool. It watches while you're developing, while you have this yarn start running or npm start running. When you make changes to a file, it'll automatically transpile that or do whatever it needs to do, and it'll serve it up to the browser and it'll refresh the browser. That is a very handy feature and helps with development. I'm going to skip it for now because I'm running out of time. So after you do that, you're going to have to set up Git, and that involves that tutorial you did earlier with Git. It would be Git init, and then you would have to commit and push your project to GitHub. And I recommend doing it pretty often. And then you will submit the link to me for a grade for your lab. So hero section. A hero section is basically a big banner. The term is pretty loosely applied to a lot of sections of websites, but basically means like this that big image you're introduced with in most websites these days. You use a background image and H1 text. So here's an example. This is the example I created for this class. The Sullivan Heights Swim Club. This whole image here with this text on top of it is a hero image. You can go to this page, you can view the source, you can check it out, but it's all going to be not completely clear how it was actually coded. So it is compiled. So if you try to look into the sources, it still looks pretty good. So you can look at this and see how I did it. And work from there. You also have to create a nav section. So that's the HTML5 nav element. And it should have 3 links. The links don't need to actually point anywhere at this point. You also notice that I have the title set and a fave icon set. You'll need to generate both of those as well for your website. And those are inside the public folder. So if we look at the folder structure of the React app, we can kill this with Control-C. Look at this folder structure real quick. We have this public that has a fave icon, index.html. You're not really going to be editing this except for very specific purposes. Where you're going to put your code is inside this source app.js. So if we open this up with TextMate, you can see there's HTML inside of here. All of this up here is JavaScript. We don't necessarily need to worry about any of that at this point. What you need to worry about is writing HTML here. Now this is going to be slightly different from the HTML that worked with in the first class. I'm going to talk about that as we go, how this is different. This is what is known as JSX. And for instance, instead of saying class equals app, you would say class name equals app. And there are reasons for that. But when we get to it, you can just look up HTML JSX converter. And generally the first, link is the best. Magic React.js.net. You can paste your actual HTML in here, and it'll give you the exact code or the exact JSX you would need to put inside the return parentheses on your site. So it changes class to class name for you. It changes your style to be the React style way. But we're going to be using CSS and the CSS file right here. So you can just specify your CSS in here and it'll magically work. So it's just opened up Sublime text editor instead of TextMate. That was my default, so messed up. All right, so that's really the intro, a crash course intro into JavaScript, Git, and the course project. This course project is due, let's see, where's the syllabus? Pull that up. So this class project is due by Friday in the week of June 19th. So it is due, show the exact day. Let's do the 23rd. There are going to be live code reviews on that day. So if you want to, and I'll talk about this next class too, if you want to schedule an exact time to go over your code, you can do it during this time frame. And I'll be glad to schedule like a 10-minute session with you to talk about your code and do a live grading of it there. So if you want feedback there, you can do that. Otherwise, we can schedule something earlier for me to look at your code, and we can talk about how it's looking or what you're thinking. And generally, it'll be done in a live fashion. So that's it for this class. Does anyone have any questions or feedback at this time? Please let me know. You can hit me up on Slack. Otherwise, it was good talking to you guys again. Talking at you guys. Hopefully we'll get more collaborative as we go, as you learn more and have more questions. All right, everyone have a good weekend. Work on your JavaScript, HTML, and CSS tutorials, and I'll talk to you all on Monday.